important concept, fuel cells. A very important fuel cells. What is a fuel cell? What is a fuel cell? A fuel cell is a device that generates electrical energy. Or already we know that fuel cell is a device which will convert chemical energy into electrical energy. Okay. So a fuel cell is one which will convert chemical energy into, you can see here, okay, generates electrical energy with the help of chemical reaction. Simply you can say that a fuel cell will convert, okay, chemical energy into electrical energy. Every fuel cell has two electrodes, as we know that. Okay, like a battery, a fuel cell is also having two electrodes. Positive electrode, that is anode, negative electrode, that is cathode. Okay, every fuel cell will have these two electrodes, anode and cathode. Okay, the reactions that produce electricity takes place at the electrodes. Okay, so where electrical energy is produced, okay, the reactions, chemical reactions has to be takes place in order to produce electrical energy, which will take place at the electrodes. Okay, so every fuel cell also has an electrolyte. Every fuel cell also has an electrolyte which carries electrically charged particles from one electrode to the other. Okay, the catalyst electrolyte is mainly used to carry charged particles from one electrode to the another electrode, and a catalyst speeds up the reactions at the electrode. Okay, so the first main objective of a catalyst will be, so it will provide a path to move the charge carriers from one electrode to the another electrode, and the second thing will be they also speeds up the chemical reactions. Okay, that is also one of the advantage. Next, coming to hydrogen is the basic fuel. Okay, hydrogen. Okay, mostly we'll use hydrogen as a chemical fuel. Okay, H2. Hydrogen is the chemical fuel we use. Okay, and also hydrogen as well as oxygen also used for the chemical reaction to produce electrical energy. Hydrogen as well as oxygen will be used to produce the electrical energy. One great appeal of fuel cells is that they generate electricity with very little pollution. Okay, you can say that fuel cells are eco-friendly and pollution free, you can say. Okay, the energy that is generated by fuel cells, will be, it is a clean energy, pollution free energy, we can say that. Okay, and pollution, much of the hydrogen oxygen is used in generating electricity. Okay, so mostly natural gases like hydrogen oxygen will be used to produce electrical energy, and ultimately combine to form a harmless byproduct, namely water. Okay, and also the output. Okay, after H and O2, if you combine, you will get a final outcome, electricity plus water will get. Water is also a harmless product. Already know that water is also a harmless product. Okay, so one detail of terminology. Okay, for example, a single fuel cell generates. Okay, for example, what we are saying, fuel cell is one which will convert chemical energy into electrical energy. Fuel cell is one which will convert chemical energy into electrical energy. It is going to produce. Okay, where? So here a single fuel cell, if you consider, very tiny or small amount of electrical energy can be generated with the help of a single fuel cell. Okay, so direct current, DC electricity it can able to produce. Okay, likewise, already know that battery is there. Battery will store energy in the form of a DC. Likewise, here fuel cell also produces DC electrical energy. In practice, many fuel cells are usually assembled into a stack. Okay, single cell is producing very small amount of electrical energy. So in practical cases, many fuel cells are combined into a stack to produce huge amount of electrical energy. Okay, cell are stacked. The principles are the same. Okay, whatever, whether it is a single cell or multiple cells, the principle will be the same, which will convert chemical energy into electrical energy that you can see. So now what we are saying, a fuel cell is one which will produce DC electrical energy, and we have a battery. Battery also produces DC energy, generates okay. So here the very important thing will be battery also a chemical device which will stores. Okay, other device generates, whether it may be a solar energy, it may be hydel energy, it may be so energy from coal based power plants or fossil fuel based power plants like gas based, oil based power plants. What is the purpose of a battery? It will store, and whenever required it will release. Okay, it is not the generator, you can say. Okay, to store energy and it will release. It is not independent generator of electrical energy. Battery only stores energy from other devices and it will release whenever required. Whereas fuel cell, okay, it is a independent generator. Direct it is converting chemical energy into electrical energy. Okay, so battery makes use of chemical concepts to store energy and releases whenever required. Okay, so that is the both produce electricity. Okay, so if it is a battery, it produces electrical energy. If it is a fuel cell, it will produce the electrical energy. However, while a battery makes electrical energy from the energy it has stored inside the battery, whatever it is stored, the same thing will be released by the battery. Okay, so our fuel cell is the independent generator, directly converts chemical energy into electrical energy. That is the major important point. This means that while a battery may run dead. Okay, so completely if the stored energy is over, okay, the battery will dead. But whereas a fuel cell will produce energy as long as fuel is available. Okay, if I keep on giving the fuel, it will keep on generating the electrical energy. Whereas battery will be completely dead once the stored energy is over. Okay, that is the major advantage of a fuel cell. For hydrogen fuel cells, okay, let us say if you consider a hydrogen fuel cell, the input will be the hydrogen. And some sort of oxygen also taken. Combination of these two things will give you the electricity as well as the water. Okay, when hydrogen in the tank runs low, you can refill it. Okay, so you can refill it or replace it with a full tank. Once the total fuel is over, you can replace it with a full tank, such that without any problem, continuously it can able to produce the electrical energy. Whereas battery, once the stored energy is over, it will be completely dead. It is not battery is not a independent generator, whereas fuel cell is the independent generator. Already we know that. Refueling versus recharging. Recharging. While there are different kinds of hydrogen tanks, and ways to store hydrogen is generally true that it's much faster to refill a hydrogen tank. Okay, so very fastly you can fill a hydrogen tank and you can insert in the fuel cell. Okay, so depending on the tank, it will take a couple of minutes. Then to recharge a battery, battery will recharge in several hours. Whereas you can recharge, here refueling or recharging is very fast in the case of fuel cells. In the case of a battery, it will several hours it will take to recharge. Whereas, in a couple of minutes you can refill the hydrogen and you can insert into the fuel cell. That is also one of the advantages of the fuel cells. Next coming to lifetime. The lifetime of today's fuel cell also a couple of years longer than batteries. batteries. Okay, already nowadays batteries we are seeing. Okay, if it completes 1.5 years, automatically the battery will be dead. Okay, so whereas fuel cell, a couple of years you can, okay, 5 years, 6 years they will be continuously work without any problem. Whereas batteries will be completely dead after 1.5 years or 2 years. 1.5 years, 2 years. Okay, batteries will be completely dead. Which give you, okay, so the lifespan of fuel cells is more when comparing with the batteries. Okay, which give less and less energy back every time you recharge them. Okay, so battery, even if you store, let us say, if you give 100%, okay, after you have to rectify it, and okay, then only you have to give it to the, okay, appliances. For example, let us say I am storing 100 watts in the battery, but it will store as a DC. The DC has to be converted to the AC. When the conversion process rectified, let us say, the efficiency will be 40%. The efficiency of a rectifier will be 40%, let us say. Okay, if the efficiency of rectifier is 40%, if 100% is given, only 40 watts only, 100 watts I have given as an input, around you will get a 40 watts as an output. 40 watts only will get a output. Okay, so then whatever you have given, that much you are not getting. That will be the major problem here. Replacing your electricity source less often saves you money over time and reduces the environmental impact of disposing recycling batteries. Okay, so it's very important point. Replacing your electricity resource less often, okay, saves you. Okay, continuously batteries are getting damaged and continuously you are repairing. Okay, so that what will happen? The cost of generating electrical energy increases. Okay, so that what you are doing? Okay, as the lifespan of fuel cells is more when compared with the batteries. Okay, so fuel cells will have, okay, it will continuously avail fuel cells. Okay, you can refill very fastly, and also the lifespan of fuel cells also very high. Lifespan of fuel cell will be very high, and also the major disadvantage of battery will be it is not a independent generator. Okay, after 1.5 years it will completely dead. Whereas fuel cell, if you continue, as soon as if you refill, it will produce the electrical energy. Okay, so these are the differences between, okay, battery and fuel cell. And next coming to what are the different fuel cells? What are the different fuels available in the fuel cell to produce the electrical energy? Okay, so the first and basic fuel which is used in fuel cells will be hydrogen. Okay, hydrogen is the basic fuel that is used in fuel cells. Next one will be hydrogen, N2H4. Next one will be hydrogen, which will be N2H4. The next one will be ammonia, NH3, which is represented with NH3, and different hydrocarbons, which are gaseous hydrocarbons will be used, and liquid hydrocarbons will be used. Synthesis gases, some synthesis gases also used as a fuel for fuel cells, and the last one will be methanol. Methanol also used as a fuel for fuel cell. Even these many types of fuels are available. The basic fuel will be hydrogen. Okay, basic and okay, so environmentally available, friendly source will be hydrogen. Most of the case will have a hydrogen fuel cells are, okay, so plays a key role in the industry. Thank you very much. We will see in the next class. Dear students, good morning to all of you. In the last class we have seen fuel cells. So already we have seen fuel cells are nothing but which will convert chemical energy into electrical energy. Okay, mainly a fuel cell consisting of a positive electrode and a negative electrode and electrolyte. These three things will be there. Okay, so in a single fuel cell we can able to generate a tiny amount or small amount of electrical energy. Okay, so normally what we will do is, okay, different fuel cells will be combined. many fuel cells will be combined into the stack to produce high and high current. A single fuel cell can generate a small amount or tiny amount of a direct current. We can say that a fuel cell is one which will convert chemical energy into direct electrical energy. Okay, so DC electrical energy we can say, DC electrical energy we can say. Okay, so next we have seen it will be just like a battery. It will be just like a battery. Fuel cell is also just like a battery. But what is the main differences between fuel cell and battery? That also we have seen. Okay, so a battery, okay, stores energy. Okay, it does not generate. Okay, it will store energy and gives energy whenever required. I can say that it is a dependent generator. Okay, so first some either conventional way or non-conventional will generate. The same will be stored in the battery, which will be used. Okay, it is not an independent generator. Whereas, okay, fuel cell, if you supply fuel, it will generate. If you supply fuel, it will generate. Okay, fuel cell is independent generator, whereas a battery is a dependent generator. Okay, it cannot independently generate if you use the fuel. Okay, first you have to store the energy. The same energy will be released whenever it is required in the case of a battery. Okay, so that is the basic concept of a battery and a fuel cell. Okay, and what about refueling or recharging? Okay, so once the battery is completely out, okay, you have to recharge it. Whereas fuel cell you have to supply the fuel. Once the fuel is out, completely out, you have to supply the fuel. Okay, so recharging takes place, okay, around 4 to 5 hours. Okay, several hours or couple of hours it will take place for the recharging. For refueling it will take only 1 or 2 minutes. 1 or 2 minutes it is taken for refueling process. That is also very, okay, within a short span of time you can refuel the, okay, so hydrogen or phosphoric acid fuel cell. Okay, mostly we have many fuels we have seen. Okay, hydrogen is the mostly used fuel cell. Okay, so very fastly within a couple of minutes we can refuel the, okay, fuel cell. And the third one will be lifespan. Lifespan of a fuel cell is very large. Okay, couple of years we have. Whereas, okay, 4 or 5 or 6 years it will be until, okay, if you provide fuel it will produce the output, long life it will have. Whereas battery will be dead within 1 year to 1.5 years only it will dead. Okay, more lifespan even for a fuel cells that we can observe. Okay, so now coming to phosphoric acid fuel cell or hydrogen fuel cell. Okay, coming to this, you can see so coming to phosphoric acid fuel cell, PAFC, phosphoric acid fuel cell, PAFC or hydrogen fuel cell, you can say. Phosphoric acid fuel cell or hydrogen fuel cell. Phosphoric acid fuel cell was developed in the year 1980. The basic phosphoric acid fuel cell is shown in the figure 12.1. This will be the, okay, figure, okay, basic phosphoric acid or hydrogen fuel cell. This will be the basic diagram. We will see later about this diagram. Okay, it consisting of two electrodes. Of porous conducting materials. Commonly, okay, 2 electrodes will be made up of nickel. Most of the cases, 2 electrodes will be made up of nickel to collect the charge. Okay, collect the charge. with the concentrated phosphoric acid filled between them to work as an electrolyte. Okay, so the phosphoric acid, okay, is filled as an electrolyte. It will have two functions. Okay, the phosphoric acid will have two functions. One will be the charge carriers will be flows through it, and it will initiate the chemical reaction. You will have, okay. So phosphoric acid is used as an electrolyte. Okay, to initiate the chemical reaction. Okay, and also charge carriers will flow from one electrode to the another electrode through the electrolyte only. Okay, pure hydrogen or hydrogen-rich gas is supplied to the negative electrode. Okay, the very important thing will be hydrogen gas is supplied to negative electrode. Hydrogen gas is supplied to negative electrode, whereas oxygen gas is supplied to positive electrode. Okay, negative electrode is called as cathode, and positive electrode is called as anode. Negative electrode is called as cathode, and positive electrode is called as anode. Okay, so to collect a charge with phosphoric acid, okay, anode. So finally, negative electrode will fill up with the hydrogen, positive electrode will fill up with the oxygen, and all this arrangement will be immersed in the, okay, phosphoric acid electrolyte. Okay, next, pure hydrogen or hydrogen-rich gas is supplied to the negative electrode, and oxygen is supplied to the positive electrode. Okay, so to come in contact with electrolyte and electrode to come in contact with electrochemical reaction. Okay, electrolyte, that is phosphoric acid, will initiate the, okay, chemical reaction. Okay, so the reaction is normally very slow, and a catalyst is required in the electrode to accelerate the reaction. This is the diagram of a, okay, hydrogen fuel cell. This you can say this will be the negative electrode. That we can call as negative electrode or cathode. And this will be the positive electrode or anode. This will be the positive electrode or anode. Okay, and the total both the electrodes are filled up with electrolyte, phosphoric acid electrolyte. This will be filled with the phosphoric acid electrolyte. So already we have discussed that electrolyte will have two purposes. First purpose will be, it will, okay, initiate the chemical reaction. Okay, hydrogen will be, okay, because of the, okay, phosphoric acid, hydrogen will be split into two hydrogen atoms plus, okay, two electrons. Two hydrogen atoms plus, okay, two electrons will have, okay, two hydrogen positive ions, and two electrons will be released because of the initiation of the phosphorus acid. Okay, chemical reaction will be initiated where the total hydrogen will be converted into two hydrogen positive ions plus two electrons. Two electrons will have. Okay, so as the, okay, two electrons are released, these two electrons, okay, are attracted and flows towards the, okay, positive side. Attraction flows towards the positive side. That movement of electrons gives rise to current, DC electrical current. Okay, because of the initiation of electrolyte, okay, hydrogen will be, okay, the chemical reaction, hydrogen is converted into two hydrogen plus ions or positive ions, and two electrons will be converted. Okay, so now these two electrons, because of attraction, it will be flows to the anode side. Okay, anode side, because this is the positive electrode. Okay, so electrons will flow through the load, which means nothing but the current. Okay, current will be, okay, generated because of the chemical reaction where hydrogen is converted into 2H plus 2 electrons. 2 electrons will move, and these 2H plus electrons will flow through the electrolyte. Okay, if the electrolyte is not there, medium is not there to flow the, okay, positive ions to other side. Okay, so electrolyte will perform two functions. First one will be it will perform the chemical reaction, and second one it will allows the charge, okay, two hydrogen atoms to the, okay, negative electrode side. As it is positive, okay, these two hydrogen atoms will move towards the, okay, so positive electrode side through the medium, okay, such that, okay, so this half O2 and 2H plus combining, you will get the water. Another reaction will be 2H plus will flow through the, okay, electrolyte, and it will combine with the half O2. Finally, we will get the water. Like this in a fuel cell. In a fuel cell, two reactions will be take place. First reaction will be H2 will be, okay, converted into 2H plus and 2E, and again which will flow through the electrolyte and combine with half O2, and you will get the water. Okay, the very important thing will be, okay, in the fuel cell, okay, the outcomes will be electrical energy you are getting, DC electrical energy, so heat will be released, and, okay, water will be released. Okay, already water is a non-polluted one. Okay, so it's a clean energy. Fuel cell energy is a clean energy, you can say that, clean energy. Okay, but somewhat heat will be generated in the fuel cells. And, okay, here platinum serves as the best catalyst for both. Catalyst, okay, generally catalyst also sometimes will use. Catalyst is mainly used for the purpose of, okay, speed up the reaction. Chemical reaction, if you speed up, okay, more amount of electrical energy will be generated, such that, okay, so catalyst is used to speed up the chemical reaction process. Most of the cases, platinum will be used as a catalyst. Most of the times. Okay, here for both electrodes are used for nickel. Okay, generally most of the cases will go with a, okay, nickel only, positive or negative electrode. Okay, sometimes you can use the nickel for negative electrode and silver for the positive electrode. Okay, whenever it is possible, based on the requirement, you will go with that. Okay, so finally, okay, divided platinum or nickel or silver deposited on the outer surface of the electrodes, okay, are used as catalyst. Okay, platinum used as a catalyst, and which will speed up the process. During the usage of the cell, the catalyst gradually loses activity. Okay, so catalyst gradually loses activity. This loss of activity is often attributed as poisoning. Okay, inactivation of the catalyst by the impurity, mostly sulfur compounds in the fuel. Okay, and next coming to, at the negative electrode, hydrogen gas is converted into, because of the, okay, so at the negative electrode, hydrogen gas is, okay, electrolyte, okay, initiate the chemical reaction. Hydrogen gas is converted, already we have discussed. Okay, hydrogen is converted to H plus and 2E. Okay, this 2H plus is combined with water on the other side, which will flow through the electrolyte, and you will have a water like this. And combining the above equations indicates that fuel cell combines H2 and O2 to produce water. Okay, the water will get. This is true for any type of hydrogen oxygen cell. The operating temperature of PAFC is 150 degrees centigrade to 200 degrees centigrade. 150 degrees centigrade to 200 degrees centigrade. At atmospheric pressure, it produces an ideal EMF of 1.23 volts at 25 degrees centigrade, which reduces to 1.15 volts yet. Okay, already we know that the temperatures keep on increasing. Okay, resistance will be increased. Okay, so likewise, because of voltage drop, the voltage will be decreased to 1.15 volts. You can say that the actual value is less than that and decreases with current. Normally, at a rated value of the voltage lies between 0.7 to 0.8 volts. Generally, at normal 25 degrees, 1.23. If the temperature is at 200 degrees centigrade, it will be 1.15. So, at a rated voltage, or at a rated current, you will have a voltage around 0.7 volts to 0.8 volts. Like this is the basic concept regarding the fuel cells. Thank you very much. జయపాల్ నేను కట్ చేసుకుంటాను.